question? Ayomide? Okay, maybe Ayomide can't hear me right now. Ozayo, did you get an answer for the green one? Ozayo, did you get an answer for the green question? Okay, let me just make sure, can everybody who can hear me right now, except the tutors, can you give me a thumbs up? And just make sure that you can hear me.
Lee Azayo has replied in the chat.
Oh, yes. I see now. Okay, so Azayo, you said minus 2x, and then I think you were meaning to say minus 1. Is that right? Okay, let's go over here and go and have a look. I got minus 2x plus 1. Did everybody else get that answer? So, okay, there's a few thumbs ups. That's great. Okay, Shaquille, thank you. Azayo, yes, lovely. Good stuff, well done. Nice. Okay, should we go and have a look at the purple one quickly? Okay, so this is what happened with the purple one. This is what I got. I got y equals 6x minus 9. And again, if you can give me a thumbs up if you got the same answer as me. I hope I didn't make any mistakes. Thank you, Malu. Maybe not everybody got a chance to do it, but that's fine. Oh, great. 5 thumbs ups. That's wonderful. Okay, even 6. Azayo, lovely. All right, well done, guys. Okay, so let's not spend any more time on that unless anybody has a specific question that they want to ask. Anybody got anything they want to ask? No, all good. Okay, all right, so let's carry on. So again, just a quick prior. Oh, sorry, Virginia, did you want to copy down the purple question? Okay, that's fine. I'll leave it there at the top of the screen, Virginia, and then you can copy it down if you want to. We're just talking about what's on the screen at the moment now, just our prior knowledge check. So in order to be able to sketch a cubic function successfully, we have to be able to say that we can do the following things. We have to be able to factorize a cubic equation. We have to be able to calculate X and Y intercepts as for normal functions. We have to be able to take the derivative to solve the coordinates at the turning points, well, the X coordinates anyway. And we also need to be able to calculate the X coordinate of the point of inflection. If you've had an opportunity to go and look at those videos that Miss G has made, then what you would know, what you would have taken away from that is that when we are talking about the coordinates at the turning points, okay, we are always talking about the first derivative. Okay, so when we see words like increasing or decreasing, because those pertain specifically to gradient, or we see the word gradient, then we know that we are referring to the first derivative. If we see a word like concavity or point of inflection, then we're talking about the second derivative. Okay, so if we see the word concavity or point of inflection, whoopsie, point of inflection, then we are talking about the second derivative. Okay, before we talk about sketching them, let's just talk about what cubic functions look like. Right, let's just move this up. Okay, so they take the general form, f of x equals ax cubed plus bx squared plus cx plus d. All right, so they have to contain the ax cubed term in order for it to be a cubic function. All right, so b could be 0, c could be 0, d could be 0, but it's not possible for a to be equal to 0. The other thing that's important for us to note is that the sign of a affects the shape of the cubic function. So if we have a look at the one that's in the middle of your screen at the moment, this is a cubic function where a is positive. So in this particular case, what we would see is that the graph would first be concave down. So when I mean concave down, what I'm talking about is this section of the graph over here. So there, it's concave down. All right, and then it would be concave up. All right, when it comes to A being negative, we see a reversal of this. So in other words, the graph is first going to be concave up and then concave down. So when I talk about it being concave up, I'm talking about this over here, its shape. Let's just highlight that for you. So here we go. It is now, whoopsie, concave up to a certain point. All right. If you have a look at all of these functions, they all have the same sort of shape. They have a local maximum. It's not a maximum as such, but it's a local maximum. So over here, this is where our local maximum is on this graph. And we have a local minimum over here as well. All right, and those function as our stationary points. If we were to draw a tangent to the function at those stationary points, the line would be parallel to the x-axis and therefore its gradient would be 0. The other thing you can note when we have a look at this is that they can have up to 3 x-intercepts or roots. So if you have a look at the first one over here, it has 1, and I'll just circle them very quickly. It has, let's just use a different color. Okay, so it has 1, 2, 3 roots or x-intercepts. So it can have a maximum of 3. Or if we have a look at this graph over here, fine, it's a different shape. It only has 2 x-intercepts. Okay, so namely over here. And again, over here. This x-intercept on the left also functions as a stationary point. And we're going to see what happens in our equation when that situation arrives. So we can have 3 roots, 2 roots, or we can have cubic functions that look like this, which is really quite an unusual shape. We don't generally end up working with these quite a lot, but they do exist. Here, they only have 1 stationary point, and that would also function as the point of inflection. So that would be where the concavity changes. All right, so here would be the stationary point. That's the point at which concavity changes, and you can see here, it's only got 1 x-intercept. All right, so they could be 1, they could be 2, or they could be 3. But most of the time, you'll be working with cubic functions when there are 2 or 3 of them. Okay, is everybody happy with that? All right, so let's get into the first sort of question that we would get on a section like this. So hopefully everybody can see that nice and clearly. Example number 1, we've been given a function f of x equals x cubed plus x squared minus 5x plus 3. All right, and the first thing that they want us to do is they want us to calculate the x and y intercepts. All right, so Rekomodetswe, if I can please ask you, how would you calculate a y-intercept of a function? What would you do? You can either turn on your mic or you're welcome to put it in the chat. Rekomodetswe?
I think you replace all the x with 0.
That's quite right. Okay, so for the y-intercept, we're going to let x be 0. And Rekomodetswe, while I've got you here talking to me, all right, do you think that it's necessary for me to show that I've subbed in 0 everywhere here? Do you think that's necessary at matric level? Or do you think I'm allowed to take a little bit of a shortcut here and just write down the y-intercept?
I think you're allowed to take a shortcut.
You're right, Rekhumeditswe, you certainly are. Absolutely. All right, so let's do exactly that. We're going to take a shortcut and we're just going to write down the y-intercept and we can write down its coordinates. And last question for you, Rekhumeditswe, and then I promise I'll pick on somebody else. Can you tell me what the coordinates of the y-intercept are?
I think it's 3.
It is quite right. So 0 and 3. All right, so those are the coordinates of the y-intercept. All right, my sweetheart, you're off the hook and let me ask somebody else. Okay, Paul, I'm going to pick on you now. All right, how would I calculate the x-intercepts? Now things start to get a little bit more interesting. How am I going to calculate the x-intercepts?
You are going to derive your f of x.
Okay, why would I derive f of x in this case? If I'm finding the x-intercepts, would I need to derive?
Oh, so you have to use the...
So you're right about deriving when we're talking about the coordinates of the turning points. Then we have to derive. But if we're trying to find, yes, Ntandukazi, if we're trying to find the x-intercepts, our rule is let y be 0. Okay, so what we would do in this case if we wanted to calculate the x-intercepts is we would say 0 equals, instead of f of x cubed plus x squared minus 5x plus 3. All right, and this is the part where I was hoping that you would have been able to watch that video on how to factorize a cubic equation. If you weren't able to do it, then I'm going to show you the way that I always teach my students to do this. But I'm hoping that we're not going to spend too much time talking about it, and that I'm going to be able to give you more of an opportunity to concentrate on calculating the coordinates of the turning points and the point of inflection and sketching. All right, so at this point over here, if I do not know what a factor is, can anybody tell me where I would start? Does anybody know where I would start? Now, I don't know what a factor of this expression is. Does anybody know where I would start? Virginia, do you know? Okay, Neo, you said 1. Okay, so does that mean that you're saying to me that if I subbed in 1, I would end up with 0 as an answer? Is that what you're saying, Neo? Oh, you didn't really check. Okay, no, you've got to check. You've got to check. So all of you at this point, what you would have done is you would have picked up your calculator. All right, so you are using factor theorem to help you with this. All right, so first you would sub in 1, then you would sub in -1. Yeah, you're right, Neo, it is. Then you would sub in 2, -2, and you would see where you got 0 as an answer. So quite right, x minus 1, if 1 gives us 0, then it means that x minus 1 is a factor. And now we need to factorize, or not factorize, but we need to work out the values of A and B and C. Okay, so we can do this by inspection. All right, and this is the part I was hoping that you guys knew how to do, but anyway, I'm going to go through it now and hopefully everybody is okay. All right, so the way that we would work out what the value of A is, we're going to start with A, is we're going to multiply the first term in the first bracket with the first term in the second bracket. So on the side over here, I would end up with AX cubed. All right, and now I'm going to go back and I'm going to look at my expression and I can see that my function is 1x cubed. All right, so I'm going to make it equal to 1x cubed. And now that I have equated my coefficients, my variables, now I can equate my coefficients. So therefore, the deduction I can make is that A is equal to 1. So in other words, this A over here is equal to 1. I'm going to go and fill that in just now. Then the second thing that I'm going to do this in a different color, is now I want to work out the value of C. So what I do is I multiply the last term in the first bracket with the C, the last term in the second bracket, and this gives me negative 1C. And again, by inspection, I go up here and I can see that it's plus 3 at the end. So it's equal to 3. So therefore, C must be equal to negative 3. All right. Now I want to work out the value of B, the one in the middle. All right. So in order to work out B, I first have to have A. I always work in this order. I do A first, and then I do C, and then I do B last. I don't know why. That's just the way that I do it. But you do need to know what A is in order to work out B. All right, so let's pick a different color, and then we can go ahead and do that. Now, when it comes to working out the value of B, we've got to multiply together this X term over here with Bx, so that gives us Bx squared. And then we also get an x squared term when we multiply minus 1 with ax squared, and that's why we need to know what a is in order to be able to do this. So we know that a is equal to 1, so this is going to be negative 1 times positive 1, so minus 1x squared, and again by inspection we're going to go up here and we're going to see that that is equal to 1 over there. All right, so that's equal to 1x squared. And again, now that we've equated our variables, we can equate our coefficients. So this means that b minus 1 is equal to 1. Add 1 to both sides, and that means that b is equal to 2. All right, so let's go down here and go and fill that in. Okay, so now that we know what these values are, we can go and pop it in. All right, so we have 0 equals x minus 1 multiplied by x squared plus 2x minus 3. Okay, and now if this resulting trinomial over here, if it factorizes, then we are supposed to factorize it. Yes, you could use long division as well, Luazi. It's not a method that I teach at my school because I personally find it a little bit more confusing. I think this method works very well. And the other nice thing about this method is that it works in every situation. You can also use synthetic division as well, but there are some instances where synthetic division won't work. So that's why inspection is my preferred method. But yes, if you want to use long division, you're very welcome. The other thing that's really important here is that it has to be equal to 0. If you end up factorizing and it's not equal to 0, you're going to lose an accuracy mark, okay, because we are solving for the x-intercept, so it does have to be equal to 0. And then we're going to factorize the resulting trinomial over here. So this is going to end up being x minus 1 times x plus 3. Okay, so now something very important emerges over here. Can you see that we've got two brackets where we've got x minus 1 times x minus 1? Does anybody know what that means? Malu, do you know what that means for us if we see this?
It means that we have turning points.
Okay, so what it means, that's right. So what it means is that your x-intercept is also going to be a turning point, quite right. So if you see a bracket multiplied by itself, that value of x is not only an x-intercept, it's also going to be a turning point. All right, so that means we've got x is equal to 1 or x is equal to negative 3 in this instance. So those are our two x-intercepts. The next thing that we need to do is we need to concentrate on calculating the coordinates at the turning points. And this is really the most important thing that we're going to talk about today. Okay, so Tsepo, I think it was you that I asked earlier what we were supposed to do here for the coordinates at the turning point. Is that right? Did I ask you, Tsepo? Okay, maybe Tsepo can't hear me right now. Okay, Sake, I'm going to ask you, do you know what you need to do in order to find the coordinates at the turning point? Do you know what the first step is? Virginia, difference of 2 squares. Are you talking about the calculating the coordinates at the turning point, Virginia? Do you substitute into the equation? Well, you're going to eventually. Okay. Yes.
Do you find the derivative?
There we go. There we go. Sorry, who was that? I didn't see who unmuted their mic.
Oh, it's me now.
Oh, okay. Well done. That was perfect. 100%. So we're going to take the derivative. All right. So now when we derive, right, hopefully all of you are saying the same things that I'm saying over here. We're taking our first derivative because we see the words coordinates of the turning point. So f prime x, that will leave us with 3x squared plus 2x minus 5 once we derive. And then does anybody know what the next step is? What's the next thing that I absolutely have to show? Live, do you know what's the next thing I absolutely have to do this? Sub the x's. Sub in the x-intercept? No, not yet. Not subbing in the x. Ah, Kanya, there we go. It must be equal to 0. Yes, Neo, and then after that I'm going to factorize. Kanya, that was perfect. Why do I have to show that the derivative is equal to 0?
Because at a turning point, the gradient is equal to 0.
Perfect. Kanya, I couldn't have said it better. That's 100% correct. Okay, so as Kanya said, the gradient at the turning points is 0. So matrix, I must write the 0 over here. You're going to get a mark for it, so you must show it. All right, so 0 equals 3x squared plus 2x minus 5. And then just as you had said, Neo, here we are going to factorize. Neo, do you know what our factors are going to be in this case? Can you tell me what to write inside brackets, Neo? I'm not fast at factorizing. That's okay. The other thing that you can also do is you can use the quadratic formula. But if it does factorize, then it's often easier to do that. Is there anybody else besides Neo that would be able to give me an answer here? Itumeleng, are you able to factorize? Could you tell me what to write here? Itumeleng, you can unmute your mic or you can pop something in the chat for us, please. Do you know how to factorize? Okay, maybe Itumeleng can't answer us at the moment. And then Shaquille, do you know how to factorize this trinomial? You're also welcome to pop something in the chat or you can unmute your mic. Shaquille, do you know?
Would it be 3x plus 5 times x minus 1?
Indeed it would. Is that you, Shaquille?
No, this is Live.
Is this Live? Okay, all right, Live. You are an absolute champ. Well done, Live. That's wonderful, 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 wonderful. Good work. Okay, so now that means that we've got, let's move that up, one turning point where x is equal to -5/3. Okay, Live, that was quite right. And another one, or where x was equal to 1. And we expected that answer. We expected that answer because up here we had a discussion and we said, well, if we had a bracket and then we saw the same bracket again, that meant that our x-intercept was also a turning point. And now we can see why it's happened down here as well. Okay, so now we're almost there. I want to try and finish off talking as quickly as I can so that I can give you guys an opportunity to do this question. What am I going to do with this minus 5 over 3? What am I going to do with this 1? Kanya, do you know? What should I do with a minus 5 over 3 now? Sub into the original, that's it, Virginia, that's it, Neo, sub into the original equation. Absolutely, I'm not subbing into the derivative because this is not a point on the derivative, this is a point on the original function. Quite right. Okay, so that's exactly what I'm going to do. So I'm going to first of all sub in f of minus 5 over 3 into the original, so that would give me minus 5 over 3 cubed plus minus 5 over 3 squared minus 5 times minus 5 over 3. Whoopsie, that's supposed to be a 3. Ooh, that's a dreadful 3. Okay, there we go. Plus 3 at the end. Okay, and then you would just pop that straight into your calculator. Don't even bother trying to work out what each term is equal to. Don't waste on that, just write down the answer. Okay, and then when I put that into my calculator, I got 256 over 27. Now, that's a pretty nasty fraction, but often our turning points end up with these really, really, really ugly fractions like that. So it is quite normal. Don't think just because you've got a nasty fraction that it's not possible. In this case, it really is possible. If I sub in 1, does anybody know what I'm going to get? Or should I even worry about it? Or do you think I could take a shortcut here? If I sub in 1, then I'm expecting to get 0 as an answer, because remember the coordinates of the other turning point? Yes, there we go. Quite right. Iomide and Neo, I would end up with 0. Quite right. Perfect. Okay, so now that means I have a turning point at minus 5 over 3 and at 256 over 27, which is 9 and something, I think 9 and 13 over 27. And then I have another turning point at 1 and 0. My Y-intercept is at 0 and 3. And my X-intercepts are at 1 and negative 3. So my X-intercepts are at 1 and negative 3. So I'm just pushing in front of me. All right, the last question before we actually go and sketch this is they wanted us to calculate the coordinate of, or the x coordinate at the point of inflection. Okay, so why is the point of inflection important for us, Matrix? Can anybody tell me why? What does the point of inflection tell us about the graph? Tandakazi, do you know? What the point of inflection tells us? Tumelo, do you know what the point of inflection tells us? Oh, sorry, Ntandakazi, this is all new for you. Okay, fair enough. If you haven't done calculus at school, this would all be very new to you. Okay, fair enough. So let me just crack on then. The point of inflection, there we go, Malu. Well done. The concavity of the graph, quite right. So that is where the concavity of the graph changes. It changes from being either concave down or concave up to concave down or concave up again. All right, so quite right. And we know that the cubic function is also symmetrical about that point of inflection. All right, so how do we calculate the coordinates at the point of inflection? So the minute we think concavity, point of inflection, we have to think second derivative or double derivative. Okay, so that means that we need to take our first derivative and derive again. So if our first derivative was 3x squared plus 2x minus 5, it means that our second derivative is going to be 6x plus 2. All right, now the measure of concavity at the point of inflection is 0. Okay, so when a cubic function is concave down, the concavity or the measure of concavity will be negative. If a graph is concave up, or in that portion where it's concave up, then concavity is going to be positive. So at the point of inflection, concavity is 0. That's why we have to show that it's equal to 0. So 0 is equal to 6x plus 2. I have to show that 0. And now I'm going to solve for x. All right, so I'm going to take the 6x over to the other side, make it negative 6x is equal to 2, divide both sides by negative 6, and this will be at negative 1 over 3. So unless they ask you, you wouldn't go and calculate this, but if the question does ask for it, then you would. And again, they haven't asked for it in this situation, but if they wanted the corresponding y coordinate, then you would take x equals minus 1 over 3 and you would sub it back into the original equation, okay? Because the point of concavity is a point on the original equation. Okay, so we're almost there, matrix. Let's now go and finally draw this graph. Okay, so we've got all our information up there, which I quickly wrote down so that would be easy for us. The best thing for you to do is to look at all the information, and rather than put like 1, minus 2, minus 3, etc., on the graph, rather draw the graph in the correct shape and then worry about your labels afterwards. So in other words, I know that my graph, because the value of a is positive 1, I know that my graph is first going to be concave down and then concave up. So in other words, I know that it has to be shaped like this, okay? I also know from what I've calculated that this point over here, this is where 1 is going to be, and that also has to be on the x-axis. All right, so, and I also know that my other turning point is going to take place somewhere in the second quadrant. So my graph, and again, I'm going to try and draw this as nicely as I possibly can. Let me just move this up a little bit. Here we go. I know that my graph has got to look something like this. Okay, so there. And then it's got to come down. Ooh, I'm not drawing this very nicely. And it's got to go like that. Now, believe it or not, that is supposed to be symmetrical about its axis of symmetry. Not the best cubic function I've ever drawn, but anyway, that will do. And now we have to label our turning points and our intercepts with axes. Okay, so if we don't do that, we're going to get marked down. All right, so over here, this was the x-intercept, negative 3 and 0. This was the x-intercept at 1, which also functioned at our turning point. Over here, this point over there was 3, if you can recall from the beginning of the lesson when we were talking about the y-intercept. And the last point which needs to be labeled is my turning point over here. Let's move this out the way. Let's just clear a little bit of space there, and now I need to label it. Okay, and the coordinates here were minus 5 over 3 and 256 over 27. All right, so I am going to be marked, or you are going to be marked, should I say, on the shape. Okay, and then there are also going to be marks for your X and Y intercepts, and then another mark for the turning points. Okay, are there any questions that you'd like to ask me? We're ready for you to start doing a question of your own. No questions? Sure. This is a lot, you're right, in Tandakazi. For someone who hasn't done trig yet, this is going to be tough for you because you don't know how to factorize. Okay, in Tandakazi, I can give you a few little hints along the way. So everybody else get started on this question. All right, so you've been given g of x equals x cubed minus x squared minus 10x minus 8. You're going to answer these questions. In Tandakazi, you can certainly answer some of them, all right? So you should be able to, I'm hoping at the least, be able to calculate the X and Y intercepts, okay? Because that's just the same as for all functions. So for your Y-intercept, let X be 0. For your X-intercept, let Y be 0. I will help you if you need me to with the factorizing of the cubic function. All right, so just get started on that. Or in Tandakazi, what you could do, if you understood how to calculate the coordinates at the turning points, you could go straight to that question if that made a bit more sense than the factorizing. It's a pleasure. I'm sorry. I know this is hard to do when it's the first time that you've heard it. Okay, is everybody else okay? You ready? You getting started? Good stuff, Neil. Okay, wonderful. If you can't factorize, use the quadratic formula. Shall I just quickly write the quadratic formula here for you? Because I think you will need to use it in this question. And then round to 2 decimal places. Okay, so the quadratic formula is as follows.
If I have the silver calculator, can I just use my calculator to solve?
Well, the answer to that is yes, but you've got to make sure that when you work backwards and you fill in your factors, that you do it in the correct manner. So in other words, if you've got, for example, let's say in one of your brackets you had 2x minus 7 and you wrote x plus 7 over 2, then you would be marked down for that. In this particular case, but yeah, use your silver calculator, it's not a problem, but you would have to show your factors still, okay? In this particular case over here, what you're going to end up finding is that this has irrational roots, so you're going to have to use the quadratic formula in this case.
Okay, thank you.
No problem. Okay, so I'm just checking, I'm not trying to be irritating, just checking, has anybody managed to do the X and Y intercepts yet? If you can give me a thumbs up. Well done, Neo. Lovely. Okay, well done, Tumelo. And Ayomide, well done. And Ozio, good stuff. Okay, so Ntandukazi, what you'll find at school is that before you do calculus, your teacher will spend time teaching you how to do this. So don't stress, they will teach you how to do this. So what you've got to do, has everybody else written down all the questions? I'm just going to scoot up a little bit for Ntandukazi. I hope so. Just very quickly. Ntandukazi, let's just go and have a look at this example over here again. All right, so when we wanted to work out the value of B in Ntandukazi, so in other words, the coefficient of the X term in the middle, there are two multiplications in Ntandukazi that you need to do, okay? The first one is the X in the first bracket with your BX, so that gives us BX squared. And then the second multiplication that you need to do is with the second term in the first bracket and the first term in the first bracket. Okay, and it is funny at first, and then eventually it does become easier. So X and BX, and then whatever this number is over here multiplied by AX squared. Okay, and then you would write it as BX squared minus, and then that's AX squared equals, and then this bit over here comes from the equation. All right, so that's why we call it by inspection. All right, so what we're doing is we're looking at it and we're saying, okay, well, I can see that the value of that is 1x squared, and that's why I'm equating it to 1x squared. Okay, Ntandukazi, I hope that helps. Okay, so I'm just... Oh, good. I'm glad. I'm sorry. I know this is difficult if you haven't done it before. Okay. Anybody else got any questions that you want to ask? Anybody else struggling with anything? I'm sure there's no questions. Sure, Sake, no problem. All right, so when you want to find the X-intercept, you have to be able to factorize a cubic equation or a cubic polynomial. Okay, so that's that bit over there, okay, Sake, where we have to first find a factor and then work out what the values of A and B and C are. So that's the part where you can do it by long division, you can do it by synthetic division, but I prefer this method. It works in all situations. So that's why I'm doing this with you. Is there anything specific that you didn't understand, Sake? Is there anything I can go through or explain to you? The third step. Okay, so when you say the third step, Sake, do you mean the step over here where I've drawn a little squiggle? Okay, all right. So this trinomial over here comes from these calculations that I had done here on the right-hand side. Okay, so I'm working out what the coefficient of the x squared term is, what the coefficient of the x term is, and then what the constant term is going to be. All right, so that's what these calculations over here on the right-hand side are for. What you need to do, Saki, the first thing that you have to do is you have to find one value that when you sub it in, that you get 0 as an answer. So in this situation over here, if we sub in f of 1, we end up with 0 as an answer. So that tells us that x minus 1 is a factor of this expression. So that's why we've written down one bracket with x minus 1. So we get a cubic polynomial by multiplying a linear polynomial with a trinomial. Okay, so that's where it comes from. All right, then we have to work out the values of a, b, and c. So when you work out the value of a, what you're doing is you're multiplying the x in the first bracket with the ax squared, and then you are having a look at the value of ax squared in the I've lost the word now, in the equation that's been given to you. Okay, so in this particular case, it was 1x squared. So you can see over here where I have made ax cubed equal to 1x cubed. And then I've said, well, x cubed and x cubed is the same, so therefore a is equal to 1. Right, and then I wrote in the 1 over there. Okay, then when I worked out the c, I multiplied the -1 in the first bracket with c in the second bracket. And again, when I go and I have a look up at the top there, I can see that my constant term is 3. So dividing both sides by -1, I get -3, and that's why I wrote the -3 over here. All right, then what I want to do is I want to go and work out what the middle term is, the b term, and that's the bit that I was explaining to Ntandikazi. So you can multiply, you get it in two ways. You've got to multiply x with bx to get bx squared, and you've got to multiply -1 with ax squared to get -1x squared. All right, and then again, by inspection, you can see in our formula, they've given us 1x squared up at the top over here. All right, 1x squared, I've put a purple ring around it already. And then once we've equated our variables, we can say b minus 1 is 1, add 1 to both sides, and that way we get b is equal to 2 from. So that, Sake, is this 2 over here. Okay, I hope that helps. I am going to have to go back down to the question now. Sure, this was a lot for one lesson. We actually needed a 2-hour lesson to do this, which is not your fault, but anyway, let's just have a look at. It's a pleasure, Sake. I hope that helped. All right, so X and Y intercepts. Hopefully we've got the coordinates of the turning points. Has anybody managed to work those out? Neo, you have. Lovely, well done. Okay, I think it's only you, Neo. Okay, so we've only got about 5 minutes of this lesson left. Okay, someone else has done a thumbs up. Tumelo, you've also got a thumbs up. Okay, that's good stuff, Tumelo. Okay, so Neo and Tumelo, try and get this done. Try and get the x value at the point of inflection, and then see if you can quickly sketch the graph. Is there anybody else who's struggling that I can help in the meantime? Okay, so unfortunately we are running out of time now. What I'm going to do is I'm going to reveal the answers to you so that at least you're able to copy these down. If we need to speak about this again next lesson, then we can certainly do so. Although I was going to do something else with you, but we can always, Neo, you're done. Oh, great. Well done, Neo. That's wonderful. This was a lot for one lesson. Okay, so let's go and have a look. Hopefully you got the same answers as me and I haven't made any mistakes here. I said that the y-intercept was 0 and -8. So hopefully everybody was able to get the same answer there as well. Then when it came to the x-intercepts, I made the equation equal to 0. I then used my calculator to determine one of the factors. Okay, Leva, you've got a thumbs up. That's nice to see. Well done. And x squared plus 3x plus 2 then factorizes into that. So x minus 4, x plus 2, x plus 1. I see some thumbs ups. That's lovely. Leva, Virginia, Iamita. Oh, great. Oh, I'm so pleased. Oh, even more thumbs ups. Oh, well done, guys. That's great. Mine was x plus 1. That's fine, Neo. Absolutely. Not a problem at all. And then your trinomial would have just been a little bit different to mine. But no, there's always more than one way to do things. No problem, Neo. Okay, so I got 3 x-intercepts, one at 4 or one at -2 or one at -1. I hope I didn't make any mistakes there. The next question, did you guys get the same answer as me? Thumbs ups. Oh, you're brilliant. You are so wonderful. Well done. Oh, look at all those nice thumbs ups. Good. Good. I know this is difficult. Nice work. Well done, Matrix. That's really great. Okay, then the second question, we had to find the coordinates. Yes, definitely big claps for you guys today. So the coordinates at the turning points, hopefully you remember to take the first derivative. You would still get a mark for that. Don't forget you must make it equal to 0. Very important to show that step. And now, unfortunately, this did not factorize nicely. Okay, but that's cool because we've got the quadratic formula. So if you're not confident with your factorizing, pop it straight into the quadratic formula, round your answer to 2 decimal places, and that's what I got. I ended up with the coordinate at one turning point being 2,19 and the other one being -1,52. Okay, Virginia, you've also got thumbs up. Good stuff. 2 thumbs up. So Rechumeditswe, you also got that. That's great. Anybody? Okay, so there are more thumbs ups. Oh, Isaiah as well. Good, well done. Well done. Okay, so we just used the quadratic formula there. And then remember, when we want to go back and calculate the y coordinate, we've got to sub back into the original equation. Okay, so I've got to sub in 2,19 and I've got to sub in -1,52. So when I subbed in 2,19, I got -24,19. When I subbed in -1,52, I got 1,38. I hope you guys got the same answers as me. Hope I'm right. Okay, Rechumeditswe, thank you. Thumbs up. And Virginia, you did too. Good. Okay, and then the point of inflection, second derivative. Oopsie, and what did I do? So naughty. I've just seen here. I needed to make that equal to 0. Okay, so I should have written 6x minus 2 is equal to 0 over there. It's naughty. I factorize, would it still be correct? Did you get the same factors that I got, Neo? Or I'd have to see what your factors were, Neo. I was under the impression that that particular trinomial didn't factorize, that there were irrational roots. But let's go 2n minus 5 over 3. Neo, are you talking about this over here? Okay, so you got, okay, hang on a second. So you said, so in your brackets, you said 3x plus 5 then, and then you would have said x minus 2. Is that correct, Neo? So that gives you 3x squared. Okay, but now the problem is, okay, so now the thing is, Neo, if you go 3x squared minus x, you get 3x squared, which is right. Then you're going to go 3x times negative 2, which is going to give you minus 6x. 5 times x is going to be plus 5x. And then positive 5 times negative 2 is going to be negative 10. Okay? The thing is that you don't get the same middle term. So the middle term here, you've ended up with 3x squared minus 1x minus 10. Okay, so you don't get the same middle term. So unfortunately, Neo, that's not going to be correct. Okay, it is what I've written over here. Oopsie, and we're almost out of time. Sorry, guys. Just going back quickly, the last thing. Okay, you understand. I'm glad. I'm sorry this has been such a rush to explain this to you. And then hopefully your graph managed to look like that. Okay, so your 3 X-intercepts and then your local max and your local min. Malu. Okay, thumbs up. Good. Well done. Oh, another thumbs up. Good. Was that Junio? Good. I'm glad. And Virginia. Perfect. Well done. And well done to those of you that struggled with this as well. I know that it was difficult and it was a lot to do in a very short space of time. Okay, so I think Michaela probably wants to chat to you. We're going to have to wrap this up. Sorry, Michaela.
It's no problem. Okay, yeah, sorry it was a rush, but I think everyone did really well. And yeah, everyone deserves a thumbs up. I just wanted to go over the homework, so I'll just share that with you now. Just another reminder, there was somebody, okay, I don't think you're aware that your name is on guest. So if somebody replied in the chat with an answer, so maybe if I tell you what your answer was, maybe you'll know if your name was guest or not. So the person said, I think it will be 3x minus 5 and x plus 1. So whoever said that, please just double check your name because it is actually on guest. So yeah, we won't be able to actually mark your attendance because it has been on guest for a while. So yeah. Okay, so yeah, just the check-in. Can everyone give us a check-in from 1 to 10? How did you find the content for today? Okay.
Yeah, and Tanjakazi, I can understand. If you haven't done this before, it's going to be very confusing. Sorry, Luyanda.
Okay.
Okay.
But still quite high, so well done, guys.
Well done, guys. That was a lot to take in one lesson.
Mm.
It really was. So, yeah, big round of applause for you all.
Okay, so just for
Definitely.
homework stuff, where to find it on the app. So we're still under calculus again. You're going to click on that. And then you will see under cubic graphs, there is increasing and decreasing functions and stationary points, part 1 and 2. So if you could please click into that and try and do that, as well as concavity and points of inflection. Sorry if I'm pronouncing that wrong.
Yeah.
Part 1 and part 2. So yeah, those are the stuff that you would need to do for our next session.
Okay. All right, guys. Thank you very much. Well done. Again, I'm sorry it was